Okay, Assalamualaikum and hi everyone. So in this video, I would like to show you how to answer question number 3 from the set 3 mock PSPM. Okay, so question 3A, from the circuit in 3.1, figure 3.1, determine the current I3. Okay, so from this circuit, we are given I1, I2 and I3, but it is not given the direction. So we can just assume the direction for I1, I2 and I3. First we assume. Okay, so don't worry about if we get the assumption wrong, because when we apply the Kerchov's rule, in the end if we get the value negative for I1, I2 or I3, that means our assumption is actually the opposite of what we assume. So don't worry about the direction. Okay, so let's first apply Kerchov junction rule. So at this junction, so the current into the junction is I1 and out of junction is I2 and I3. Okay, so let's write down Kerchov first rule is current into the junction is equals to the total current out of junction. So into the junction is I1 and out of junction is I2 plus I3. We can rearrange that, becomes I1 minus I2 minus I3 equals to 0. Okay, let's leave that is equation number 1. Okay, and then we can apply Kerchov's second rule. So from at the top of the circuit, let's draw a loop. So it doesn't matter if we draw clockwise or anti-clockwise. So let's just draw it as anti-clockwise. And then just draw a little bit of direction of the EMF, which is from negative to positive. Okay, and then let's apply Kerchov's second rule. Okay, so the EMF 7 volt is opposite, the opposite direction with the loop. So opposite direction, okay, I just write the concept. Total EMF equals to total R. So just now 7 volt is negative because opposite direction. Okay, so negative 7. And the other one, 3 volt is also opposite direction with the loop. So let's make it negative 3. So minus 3. Okay, and then we look at the resistor. So the 2 ohm has a current I1. So I1 is same direction as the loop. So we make it positive. So positive 2 I1. Positive 2 I1. Okay, and then 9 ohm has the current I2. So I2 is also same direction with the loop. So that means it's positive 9 I2. Okay, so we solve this. Negative 10 equals 2I1 plus 9I2. Okay, well, let's make it equation number 2. And then we draw another loop at the bottom circuit. Okay, it doesn't matter clockwise or anti-clockwise. So let's say I make it anti-clockwise. And we draw direction on the EMF. Okay, so for the third equation, okay, so the EMF on 3 volt is same direction as the loop, so that means it's positive. So let's write it as positive 3. And the other one, 8 volt, is also same direction with the loop, so we make it positive 8. Okay, and then the resistor 9 ohm has the current I2. So I2 is opposite direction with the loop. So that means it's negative 9 I2. negative 9I2. And the other one is 5 ohm, the current I3. Okay, so it's the same direction as I3, so it's positive 5I3. Okay, so we solve this as 11 equals to negative 9I2 plus 5I3. So let's make it equation number 3. And then from the three equations that we have written down, so we solve to get I1 equals to negative 0.562 ampere, I2 will be negative 0.986 ampere, and I3 would be 0.425 ampere. Okay, so since we got I1 and I2 as negative value, that means that the direction that we have assumed is actually opposite. Okay, so no worries about that. Right, so for question number 3A2, so we want to determine the number of electrons that pass through the 9 ohm resistor in 2 seconds. So the 9 ohm resistor has the current I2 that passed through the 9 ohm resistor. So from the previous question, we already calculate that I2 is equals to negative 0.986 ampere, where the negative is just to show that the direction is actually the opposite of what we have assumed. So this negative we can just ignore because we just want the magnitude of the current, which is 0.986 ampere. Okay, so we want to find the number of electrons. So we know that the relationship between number of electrons and charge is equals to the number of electrons times the charge for one electron, and the total charge is also equals to I times T, which is current times time. And if we rearrange this equation, we get that number of electron equals to IT over E. Okay, so we substitute current 0.986 times with time in 2 seconds, divide by the charge is 1.6 times 10 power negative 19. So we will get the answer 1.2325 times 10 power of 19 electrons. And then for question 3A3, calculate the power dissipated by the 5 ohm resistor. Okay, so we have calculated that the current through 5 ohm resistor is I3. So previously we know that the current I3 is equals to 0.425 ampere. So we know that power equals to I squared R. So we can straight away substitute 0.425 squared times R. The resistance is 5 ohm. So that will give you 0.903 watt. Right, and then for question 3A4, we want to determine the change in resistance of the 2 ohm resistor when there is a 30 degrees Celsius rise in its temperature. And it's given the coefficient of resistivity is 6.8 times 10 power of negative 3. Okay, so the information that we're given is the rise in temperature is 30 degrees Celsius, and the coefficient is 6.8 times 10 power negative 3 per Celsius. And we know that the initial resistance is 2 ohm. Okay, so from the equations, R equals to R naught 1 plus alpha delta T. Okay, so this one becomes R naught plus R naught alpha delta T. and we bring that to here is R minus R naught is R naught alpha delta T, or R minus R naught can be considered as the change in resistance. Change in resistance equals to R naught alpha delta T. Okay. And then we substitute the values delta R. So R naught is 2, alpha is 6.8 times 10 power of negative 3, and the change in temperature delta T is 30. So that will give you 0.408 ohm.